Hello friends, good afternoon. Myself Dr. M.H. Annaya. Friends, in today's video, we are going to learn some basic concepts about the projection of a line. Friends, basically, there are some 8 to 9 different positions the line can take. So, just before we start with different cases of lines lying in different locations in the first quadrant, let me explain to you what is VP, what is HP, what is XY, the profile planes, etc. Friends, when you are sitting in a room, the wall in front of you is the vertical plane, which is represented by VP. The floor on which you are sitting or I am standing is the horizontal plane that is represented by HP. The wall to your right side is the right profile plane and the wall to your left is the left profile plane. So friends, let us take up different cases of lines lying in different quadrants. So friends, first of all we should know what a line is. Line is defined as the shortest distance between two points. So friends, if you have a point A here, point B here, A and B, we can reach point B from A by following different routes like this, like this, like this, and there are such innumerable number of ways or the paths we can follow to reach B. But there is one path which is the shortest between these two. So the line connecting A and B by the shortest route is the true length of a line or a line to say. Friends, here we are going to take up different cases of lines lying in different position in between VP, HP, right profile plane and the left profile plane. Let me start with case number 1. Case 1, you have a line on HP parallel to VP. Suppose you have got a line, for all this you take line as AB. AB is the line that is on HP parallel to VP. Friends, if you take my hand as the palm as the HP and this you can take it as a line. Friend, here this is on HP, and while teaching you the problems on the projection of points, I told you whenever any point is on HP, its front view is obtained on XY. So I am going to write down a line here called XY, and here I mark VP and HP indicating first angle projection that is followed to obtain the projections of this. So when the line is on HP and is parallel to VP, let it be anywhere on this HP. Since it is on HP, it is seen as a point in the front view. So line, sorry, it is seen as a line. So this is A dash B dash, the front view of the line, and the line is parallel to VP. So we are going to get this AB is the top view of the line, this is the front view of the line. So how to obtain this, friends? So when a line is parallel to HP, sorry, parallel to VP and on HP, you can see it as a line in the top view and as a line in the front view. So you will be able to get same length both in the front view and in the top view. That is to say, in this question, A dash B dash is equal to AB. This is the front view and this is the top view. How to obtain this? Friends, whether the line is parallel here or here or here, anywhere when it is parallel, the distance of that line from the VP can be seen in the front view. Suppose this line is at a distance of 30 mm, so that can be seen in the top view. So we write a line first here, AB, the top view. We project lines from there and obtain A dash B dash in the front view. So we can generalize whenever a line is lying on HP, whether it is parallel to HP or inclined to, parallel to VP or inclined to VP, it is seen as a line. So in this particular problem, since this is parallel to both, that is HP and VP, and I given here, it is on HP parallel to VP. The front view and top view will have the same length. Front view is seen as a line on XY, top view is seen also as a line at the given distance. Both because both A and B will be equidistant from the vertical plane. So this is one such important problem. So friends, let's move on to the case 2 or second case. Suppose you have line AB on VP on the vertical plane and that is parallel to HP. It is on VP and parallel to HP. So friends, when this is on VP, is the board in front of it is the board. So front view is going to be a line. It is parallel to VP, is on VP. And when you see from the top, suppose this is end A and this is end B, the shadow of this falls on XY, and XY is the line of intersection of VP and HP. So when the line is on VP, the front view is going to be a straight line of the given length, maybe 90 millimeter, whatever it may be. And the top view you are going to get on XY. So it is on VP and parallel to HP. They will give you from HP what is the distance. So friends, to obtain its projections, we draw a horizontal line, name it as XY. The line is on VP. So top view is seen here, and front view you are going to get here above the XY line at the given distance. They may specify the end A. This is A dash B dash. The end A or B is 20 mm above HP. So this is going to be the front view, A dash B dash, and this is the top view, which is called AB. So this is obtained by drawing projectors from there. This point is A and this point B, and compulsorily you have to mark VP by HP, indicating the first angle projection. So friends, we can generalize that whenever a line is on VP and it is parallel to HP, it is seen in its true length in the front view and also in the top view. In other words, the length A dash B dash is equal to length AB. So all these will have the same length. I hope you are following. And let's move on to case number 3. Line AB is on XY. The complete line is on XY. So what's the meaning of that? The line of the given length, when I say line, it's always a straight line. It is on XY. On XY is, it is on the line of intersection of VP and HP. Friends, mark XY. The line is on this. So both in the front view and in the top view, you get the projections on XY. So I will mark here the line of the given length, and I will mark A dash, B dash. Suppose the length is 90 mm, we will mark it as 90 mm here. And what is the top view? This front view is A dash, B dash, and top view is AB. So both front view and top view are represented by this line on XY, and here VP by HP you will have to mark. So friends, we have studied three different positions of the line. Let's move on to the fourth, case number 4, line on VP and inclined to HP. Inclined to HP. Friends, you have got a line on VP, means it is lying on the wall and it is inclined to HP. So inclination to HP is this angle. So friends, whenever the line is on VP, the true length of the line is obtained in the front view, that is above the XY line. Suppose the line is measuring 90 mm, you are going to get A dash, B dash inclined at the given inclination. So front view you see the true length, and when you look from the top, the length of this line depending on its inclination with HP is reduced. So friends, whenever the line is on VP, you can see the true length of the line in the front view, and also the angle made by the line with the HP can be seen in the front view. So friend, how to obtain the projection of such a line? So as usual, mark XY, mark VP and HP, and he says the line is inclined. So I will just draw a line, say of the given length 90 millimeter at the given angle, say 40 degree. That will be specified in the problem. So when you actually take up the problem, we will do it in detail. So friends, here you have got the line AB, which is parallel to, is on VP and inclined to HP at an angle. And how to obtain the top view? I told you, when you see the ends A and B, the shadow of these points fall on XY. So if you project from there, you get this as point B and this as point A. So here friends, AB will represent the top view, A dash B dash will represent the front view, and the inclination of the line and its true length can be seen in the front view. So this is the projection of a line inclined to HP and line is lying on VP. Friends, you can see here there are lines connecting A dash and A, B dash and B, and these two lines A dash A and B dash B are called the projectors or end projectors of the line, and the distance between A dash A and B dash B is represented by DEP. DEP means distance between end projectors. It's always measured parallel to XY. So this is called DEP. DEP means distance between end projectors, where A dash A and B dash B are two end projectors. This concept we are going to work out when you take up the actual numerical examples in further videos. Let's move on to the fourth case. Case number 5, sorry. Line parallel to HP and inclined to VP. Inclined to VP. You have got a line, say some length, say 90 millimeter. It is, line is, you can say on this side, you have got a line here. It is line parallel to HP and inclined to VP. Look here friends, This line is parallel to both HP and VP, and if you rotate like this is parallel to HP and it is inclined to VP. The inclination of the line can be seen in the top view. So when you have a line like this line AB is parallel to HP and inclined to VP. The true length of the line is seen in the top view. When you look from the top, you can see the actual length, that is a 90 millimeter. But in the front view, depending on the inclination the line is making with VP, you will get a shortened length. One point from here, one point from here. You get a shortened length in the front view. So friends, to draw the projections, we will mark the XY line, mark VP and HP. The line, I told you, this line can be seen in its true length in the top view. So I am going to write a line here. I call that as A, comma B, as AB, and say this has got a length equal to 90 millimeter, and this is inclined at an angle of say some 30 degrees to VP. The inclination to VP can be seen in the top view. So friends, after getting this, in the front view I told you, you are going to get a line parallel to XY. So I'll write a vertical line from here, a vertical line from here, and depending on the distance, you are going to mark here the front view represented by A dash B dash. This distance of the end A or that of B will be specified in the problem. Friends, A dash B dash gives you the front view and AB gives you the top view. Top view is TV. So you have to darken this line A dash B dash and this line A comma B, that is AB. Friends, you can have a very important inference from this problem, that is whenever the line is parallel to HP, the corresponding top view will give the true length and vice versa. Suppose the line is parallel to HP, the corresponding front view will give the true length, because this is a very important concept and this we are going to apply in the actual problems on the lines. So friends, this is parallel to HP and this is inclined to VP at an angle that will be specified in the problem. Friends, we are moved to the fifth case, that is the case of a problem where this is perpendicular to HP. Friends, I have a line here A, B. A at the top, say B at the bottom. This line is perpendicular to HP. Say this is got a length equal to 90 millimeter. Friends, when you look in the front, from the front, you see the shadow of this line on VP. So you can see the true length of the line in the front view on VP, which you represent this as A dash B dash. And if you see from the top, look from the top, you see the line as a point. If A is near, you'll be able to see A and B is covered by A. So whenever a line is perpendicular to HP, it is seen in its true size in the front view, which is obtained on VP. In the end view also it can be seen in its true length, and in the top view you see it as a point. So for this I'll write down line perpendicular to HP and parallel to VP. Parallel to VP. So it is very obvious, whenever a line is perpendicular to HP, it has to be necessarily parallel to VP, parallel to the right profile plane, parallel to the left profile plane. You can see the true length in the front view, in the side view, they're both left and right hand views, and there's a point in the top view. So how to represent it in 2D? We mark the XY line, mark VP and HP to indicate first angle projection. Then front view I told you, you are going to get perpendicular to xy, and suppose say this has got a length 50 mm. So this is going to be your A dash, B dash. The front view, say the length of the lane is 50 mm, and I told you the top view is going to be a point. This point is going to be A comma B. AB is the top view, A dash B dash is the front view, and in the side view if required you will get the same length. And friends, see here in this problem you may ask me what should be this distance. It will always be specified in the question at what distance the line is from VP. Is it 30 mm, 50 mm, 70? If it is 30, I am going to mark 30 here. If it is 70, I just mark AB here, and so on. So we can draw the conclusion here for this. Whenever the line is perpendicular to HP, that is obviously parallel to VP and to the right profile plane, it is seen as a line in the front view with the true length and as a point in the top view. Friends, let us move on to the next case of problem when the line is perpendicular to VP. So this is line perpendicular to VP. So friends, it's very simple, and at home also to study such problems on line, you can have a pencil or a scale like this. Sit, imagine the room in which you are sitting has got VP, the front wall, left and right profile planes, and you can, on that basis you can work out a lot of problems. There's a line that is perpendicular to VP. Friends, this is parallel to VP, this is perpendicular to VP. Say this line has got a length of 90 millimeter. What is that you see in the front? When you see in the front, this line, since it is perpendicular to VP, you see it as a point. And after getting the shadow of this line on HP, if you look from the top, you will be getting the true length of the line. So, to represent in 2D, we mark XY, and I told you since it is perpendicular to VP, it is seen as a point here. I will mark it as A comma B at the given distance. Write a vertical from there and mark this the top view, that is AB, to the given length, maybe 90 mm. If it is 90, you should take, and this is A dash B dash. This will represent the front view, and this AB will give you the top view. The top view of the line is AB, which will be 90 millimeter long. Front view is a point, and end view is also going to be a line of same length. Both the left hand view and the right hand view will have the same length, 90 millimeter. Friends, I hope you are all following the procedure I'm using to solve problems on lines. Friends, there is a very important case which everyone comes across while doing problems on the projection of lines. That is the last type. That is a problem where the line, the given line, is inclined to both HP and VP. Let's see how does it look. Friends, you have a line here. Suppose this end is A and B. Now AB is parallel to HP, is parallel to VP. You see the true length both in the front view and top view. Therefore, front view length is equal to top view length is equal to the actual length of the line. For example, friends, if you have like this, line is parallel to VP, front view A dash B dash will give you the true length, top view is a reduced length, and the inclination to HP can be seen here. Friend, if you have a line like this, so it is parallel to both HP and VP, parallel to VP, inclined to HP, and if you have like this is the important case of problem which is in where the line is inclined to both HP and VP. So whenever the line is inclined to both HP and VP, we will not be able to obtain the front view and top view of the lens, or it is not seen in its true size either in the front view or in the top view or in the end view. So we are going to work out number of such problems when the line is inclined to both HP and VP. Friends, I hope you are happy with the presentation I have made on the basic concepts of projection of lines which lies in the first quadrant. And if you are happy with my presentation, do pass on the information to all your friends. Have a wonderful day, friends.